Okay, you've probably seen the headlines. AI models are suddenly, well, acing IQ tests.
Yeah, it's kind of everywhere, isn't it?
Totally. We're talking about OpenAI's O3 hitting a score of 136 and Google's Gemini 2.5 Pro breaking into the 130s.
Pretty impressive numbers on the surface.
Right. But here's the crucial bit and why we're doing this deep dive. These scores, they need a huge asterisk next to them. They don't necessarily mean AI is suddenly smarter in all the ways that, really matter.
That initial reaction of, wow, but also, wait a minute, is absolutely spot on. We need to unpack this.
Exactly. So this deep dive is all about figuring out what these numbers really tell us.
Because for, over a century now, we've used human IQ tests, going back to Alfred Binet's work, to gauge cognitive abilities.
The standard approach.
Right. And these tests are really carefully calibrated, using results from huge numbers of people, different backgrounds, setting that average score at 100, standard deviation of 15.
And it's become our shorthand, almost, for understanding how smart someone is, maybe even predicting academic success, things like that.
It has. It's a familiar framework.
Yeah.
Which makes the AI situation so, different. For a long time, AI wasn't even really playing in this league.
Not at all. It's kind of wild to think that way back in the 90s, AI would have just been guessing on these things.
Pretty much random chance level, yeah.
And even, 2020, GPT-3 was blowing us away with language, but on things like Raven's matrices, those visual puzzles.
The score was only in the high 70s.
Right, like a bright 7th grader, the sources said. Impressive for code, sure, but not exactly human-level reasoning across the board.
No, not threatening the human average, let alone the top percentiles. And that's why what's happening now feels so significant.
It's the speed, isn't it?
It's the velocity. We're seeing O3 at 136, Gemini 2.5 Pro around 130, Claude 3 just over 100, DeepSeek R1 also around 100, even Grok 3 in the low 90s.
So jumping from below average, like that high 70s score, to the very top percentile in just, 2 years?
It's an absolutely massive leap, almost unprecedented if you think in human terms.
Which makes you step back and ask, okay, what are we actually measuring here? Especially when we apply these human tests to AI.
How do you even do that fairly? How do you adapt a test designed for humans, with our experiences, for a machine?
And yeah, ultimately, what do these impressive 2025 scores really signal about AI capabilities? And maybe more importantly, what don't they tell us?
That's the core of it. What are the limitations? That's what we really need to explore.
Okay, so let's get down to basics first. Human IQ. We mentioned Binet, the 100 average. But what's the core idea? What does it try to measure?
Well, the general consensus in psychology is that IQ represents general cognitive ability. It's often called the G factor.
G factor, right.
Think of it as like your overall mental horsepower. And standard tests like the Wechsler Adult Intelligence Scale, the Weighs the C, is a common one. For adults, they try to assess this G through 4 main areas.
Okay, what are those?
So first, you've got verbal comprehension. That's vocabulary, understanding analogies, general knowledge about the world.
Makes sense.
Second is perceptual reasoning. This is more about visual stuff, solving spatial puzzles, completing patterns, figuring out visual logic.
The shapes and blocks kind of questions.
Exactly. Third is working memory. This tests how well you can hold information in your mind and manipulate it, like remembering a string of numbers and repeating them backwards, or doing mental arithmetic under time pressure.
Okay, holding and working with info.
And fourth is processing speed. This measures how quickly and accurately you can perform simple, often repetitive tasks, like matching symbols to numbers based on a key.
So it's testing different kinds of thinking, really. Speed, memory, verbal, visual.
Precisely. And these tests aren't just thrown together, as you said earlier. They're carefully constructed and normed. Meaning they're tested on very large, diverse groups of people, different ages, educational backgrounds, cultures, to establish what an average performance looks like. That's how they set the 100 score. And they have to keep doing this periodically, renorming the tests. Because average scores tend to creep up over generations.
Oh, yeah, the Flynn effect. Right.
Yeah.
We're getting better at taking tests. Or maybe something else is going on.
Well, that's a whole other debate. But yeah, the effect is real. So the tests need regular updates to keep 100 as the true average.
And the key thing for humans is that doing well requires flexibility, right? Engaging different brain parts.
Exactly. Solving a visual puzzle uses different cognitive skills, different brain regions, than understanding a verbal analogy. So a human IQ score reflects, to some extent, this flexible thinking across different domains.
Okay, that makes sense for us. But now the big pivot, applying this to AI. How on earth do you test something that doesn't have eyes or hands or, a brain like ours?
That is the million-dollar question, isn't it? It's a huge challenge.
Yeah.
These large language models, they don't see visual puzzles. They don't manipulate physical blocks.
They just process text.
Primarily, yes. So researchers have had to get creative. Essentially, they have to translate these visual or procedural tests into a text-based format the AI can understand.
How does that work in practice, like for those matrix puzzles?
So a common method, say for the Mensa Norway matrix test, which is often used, is instead of showing the AI a 3x3 grid of shapes with one missing.
Which it can't see.
Right. The puzzle is described in words. The prompt might say something like, imagine a 3x3 grid, top row, a black circle, then a white square, then a black triangle, middle row, a white circle, a black square then, and so on.
Describing the whole pattern verbally.
Exactly. And then it'll say which option completes the pattern, followed by multiple choice options, A, B, C, D, also described in text. Option A, a white triangle. Option B, a black circle.
And the model just picks a letter.
It chooses the letter corresponding to the description it thinks best fits the pattern.
Wow. Okay, I can immediately see how that could get fuzzy. The way you describe the shapes could make a huge difference.
It's more than just fuzzy. The researchers literally call it a minefield.
A minefield.
Really?
Yes, because the exact phrasing of that prompt, the order you list the features, like do you say black small circle or small black circle? Even subtle choices can significantly impact the model's performance.
That sounds less like testing intelligence and more like testing how well you can guess the magic words.
Well, it's led to this thing some people jokingly call prompt alchemy. Finding just the right wording to get the model to understand the task feels almost like casting a spell sometimes.
Huh. Prompt alchemy, I like that.
But there's an even bigger issue lurking here, too.
Which is?
Data leakage or contamination.
Meaning the AI might have already seen the test questions.
Exactly. Many of these IQ tests, especially the ones from publicly available sources like Mensa practice sets, are all over the internet. They're in forums, blogs, maybe even digitized books.
And the AI's training data is scraped from the internet.
Billions and billions of web pages. So it's highly likely that these models have encountered many of these specific questions during their training.
So it's like studying for a test by memorizing the actual answer key.
It's kind of like that, yeah. It gives them an unfair advantage, potentially inflating the scores. Because they're not solving it fresh, they might be retrieving a stored pattern.
Okay, that definitely throws a wrench in interpreting these scores as pure reasoning ability. What are people doing about that? Can you even test them fairly?
Well, people are trying. Groups like TrackingAI, for example, are working hard to create completely new, unseen test sets.
Like puzzles that have never been online.
Exactly. They develop proprietary questions and often administer the tests from secure offline servers to minimize any chance the model could have seen them during training.
And do the scores change on these clean tests?
Oh, significantly sometimes. The O3 example is really telling. That headline score was 136 on the public Mensa set, right?
Right, the one that got everyone talking.
But on TrackingAI's offline, presumably unseen version, the score dropped to 116.
Wow, a 20-point drop. That's huge.
It is. It strongly suggests that prior exposure, that data leakage, was indeed inflating the public score quite a bit.
Okay, so 116 is still very high, well above average.
Absolutely. Even the leak-proof scores are still remarkably high compared to just a few years ago, indicating a real jump in some kind of capability. But it highlights why you need that asterisk.
Yeah, context is everything. Which brings us back to that 2025 leaderboard. Even with the leakage caveat for public scores, the overall trend, that speed, seems real. Can you just run down the rankings again quickly?
Sure. So as of now, roughly mid-2025 based on release dates. OpenAI's O3 from April 25 leads with that public 136, dropping to around a 116 offline.
Okay.
Google's Gemini 2.5 Pro, March 25, is around 130 public, maybe 118 offline, quite close. Anthropic's Claude 3, which is a bit older, early 2024, was scoring just over 100 on public tests when it came out.
Still above average.
Yep. DeepSeek R1, January 25, is right around that human average, 100 or so. And xAI's Grok 3, February 25, seems to be in the low 90s.
So a definite hierarchy, but everyone's moving up compared to before.
The whole field is shifting upwards, fast.
And it's that rate of change that's just mind-boggling. You mentioned GPT-4 scoring 85 in early 2024.
Right below average.
And then O3 hitting 136 just over a year later. That's a 51-point jump.
It's immense. One of the sources used an analogy I thought was striking. It's like a teenager growing from 5.5 feet tall to over 9 feet tall in a single year.
Whoa. Okay, yeah, that puts it in perspective. It's not normal growth.
Yeah.
So what's driving this? What are the key technical reasons these AIs are suddenly getting so good at these specific tests?
It's a combination of factors, really an R&D arms race. But some key things stand out. First, and maybe the most obvious, scale, scale, scale.
More data, bigger models.
Massively more training data than their predecessors. And also, crucially, much larger context window.
Context window, that's like the AI's short-term memory.
Kinda, yeah. It's the amount of information the model can hold in mind and actively consider when it's working on a problem. Bigger windows let it process more complex prompts and maintain longer chains of reasoning, which helps with multi-part puzzles.
Okay, so bigger brain, better short-term memory. What else?
Another really important one is mixed modality embeddings.
Sounds fancy. What is it?
It means that even though the IQ test might be given purely as text, many of these advanced models, like O3 and Gemini 2.5, were pre-trained on enormous datasets containing both images and text linked together.
Ah, so even if they aren't seeing the puzzle now, they've learned relationships between visual concepts and words.
Exactly. It seems to give them a kind of latent underlying visual understanding, or at least a better grasp of spatial relationships described textually. Think of it like a student who's seen countless diagrams. Even if the test question is just words describing a diagram, that prior visual exposure helps them mentally picture it.
That's fascinating. Learning from pictures helps ace a text test. Okay, what other tricks are they using?
Well, two other techniques are really boosting performance on these kinds of problem-solving tasks. One is called self-consistency sampling.
Self-consistency.
Yeah. Instead of just generating one answer, the model is prompted to generate multiple different possible solutions or reasoning paths for the same problem, sometimes dozens.
Okay, then what?
Then, it essentially looks at all the final answers it generated across those different attempts and picks the answer that appeared most frequently. It's like taking a vote among its own internal reasoning processes.
Ah, so it kind of checks its own work by trying multiple ways and seeing what answer keeps coming up?
Precisely. It helps weed out fluke answers or less reliable lines of thought and converge on the most robust solution it can find.
Clever. And the other technique?
That's chain of thought fine-tuning. This is a big one. Researchers are explicitly training models not just to give the answer, but to explain their reasoning step by step.
Like showing your work in math class.
Exactly like that. They fine-tune the model by rewarding it for outputting a logical sequence of steps leading to the answer. And paradoxically, making the AI think out loud like this often improves the accuracy of the final answer.
Why would explaining help it get the answer right?
It seems to force the model to follow a more structured, logical path. Plus, it's incredibly useful for the developers because they can see how the model arrived at an answer and debug it if the reasoning is flawed.
So scale, context, learning from images, self-checking, and showing its work. That's quite a toolkit.
It really is. And these techniques, combined with sheer computational power, are what's driving this rapid ascent up the IQ score charts.
It definitely sounds like they're getting incredibly skilled at taking the test. But this brings us back to the caveats. Are these scores telling us the whole story? What are the dark corners, as the sources put it?
Absolutely. We need to talk about the limitations. There are some significant ones. One we already touched on is that extreme prompt sensitivity.
Right, the slanted versus angled example.
Exactly. A tiny, almost insignificant change in how you phrase the question, a change a human would likely ignore or easily understand, can completely throw the model off, flipping its answer from correct to incorrect.
Which suggests the understanding isn't very robust, maybe.
It seems less robust than human reasoning in that respect, yes. Another key issue is the difference between what's called meta-memory and genuine understanding.
Meta-memory, like memory about memory.
Sort of. It means the model can sometimes describe a pattern or a rule correctly, but then fail to actually apply that rule accurately to solve the puzzle.
Can you give an example?
Yeah, the source mentioned a case where a model might correctly state, this grid exhibits rotational symmetry. It recognizes and can name the concept.
Okay.
But then, when faced with picking the missing tile, it might choose a tile that violates that symmetry, perhaps because it matches some other superficial feature. It described the rule, but didn't truly internalize or apply it. The example was missing a blank tile needed for symmetry.
Ah, I see. It can talk the talk, but not always walk the walk, conceptually speaking.
That's a good way to put it. It highlights a potential gap between pattern description and deeper comprehension.
What else? Are there other ways these scores might be misleading?
Well, there's also this contrast between one-shot brilliance and multi-step fragility.
Okay, meaning?
Meaning these models can often nail individual, well-defined problems, like a single matrix puzzle, which looks brilliant.
Right.
But they frequently struggle with tasks that require stringing together multiple steps of reasoning, where the output of one step feeds into the next.
Like a more complex, multi-part problem.
Exactly. Google developed a benchmark called Humanity's Last Exam, which involves needing to synthesize information across several paragraphs and perform sequential deductions.
And how do the AIs do there?
Even the top models, like O3, still score quite poorly on it compared to average human accuracy. They seem to get lost or make errors when the reasoning chain gets longer.
So good at sprints, maybe not so good at marathons yet.
That's one way to think about it. And we also can't forget the no-stakes factor we mentioned earlier.
Right. The AI isn't nervous or tired.
Exactly. A computer doesn't suffer from test anxiety. It doesn't get hungry or distracted. Its performance doesn't flag after hours of testing like a human's might. If you could somehow remove all those real-world pressures from a human taking the test, their score would likely go up too. It's not an entirely level playing field in that sense.
That's a fair point. And beyond these specific test-taking issues, is there a really big fundamental blind spot these IQ scores have when it comes to AI?
Oh, absolutely. The elephant in the room, really.
Yeah.
These scores tell us virtually nothing about alignment.
Alignment meaning if the AI is safe, ethical, shares our goals.
Precisely. That absolutely critical question. Are the AI's goals and behaviors actually aligned with human values and well-being? A model can be a whiz at solving abstract logic puzzles.
Get a 130 plus IQ.
And still be perfectly capable of generating harmful misinformation, biased outputs, or dangerously flawed advice if prompted the wrong way, or if its underlying goals aren't properly constrained.
So high IQ doesn't equal trustworthy or beneficial.
Not even close. Things like common sense, wisdom, ethical judgment, maybe even creativity. None of that is captured by a single IQ number derived from these tests.
Okay, so if these AI IQ scores have all these serious limitations, prompt sensitivity, meta-memory issues, multi-step problems, no stakes, and especially the alignment blind spot, what are researchers looking at instead, how else can we try to get a real handle on what AI can and can't do?
Yeah, that's the crucial next step.
Yeah.
There's a definite shift happening towards developing much broader, more diverse suites of evaluations. We need to go way beyond just IQ.
Like what kind of things?
Well, for instance, there's the ARC-AGI benchmark. This focuses specifically on abstract reasoning challenges that are designed to be easy for humans, but historically very difficult for AI, requiring flexible intelligence.
And how does something like O3 do on that?
Interestingly, very poorly. The sources say its performance on ARC-AGI is still only comparable to maybe a young child, like a 10-year-old, despite its high IQ score.
Wow, okay. That shows the gap.
It really does. Then you have benchmarks looking at specific advanced skills, things like competition-level math problems, Math 500, A&E challenges.
High school math Olympiad stuff.
Pretty much. And some models, like DeepSeek R1, have shown surprisingly high accuracy there, probably because they've been heavily fine-tuned on mathematical reasoning data. It shows strength in a narrow domain.
So specialized training works. What about more practical skills, like coding?
Yep, there are benchmarks, like SWE Bench and GitHub Bugs, that evaluate real-world coding abilities, fixing bugs, writing code snippets. Current top models are scoring around, say, 50% accuracy on some of these.
So helpful, but you wouldn't want it writing safety-critical code on its own yet.
Definitely not reliable enough for that yet. And then there's the really challenging frontier, trying to assess ethics and values.
How do you even test for that?
It's very early days. Researchers are developing prototype tests, things like ethical twins or value alignment benchmarks, where they present models with moral dilemmas or scenarios involving conflicting values.
And the results?
Highly sensitive to prompt phrasing, as you might imagine. It's incredibly difficult to objectively measure something like moral reasoning in an AI right now, but people are trying.
So the big picture is moving away from one number.
Exactly. Moving away from relying solely on IQ towards creating a much more comprehensive report card for AI, assessing a whole range of capabilities and, crucially, limitations.
It really underscores just how different human and artificial intelligence fundamentally are, doesn't it? It's not just about scores.
Oh, profoundly different. It's like comparing, I don't know, apples and supercomputers. They might both be able to calculate, but the way they do it and everything else about them is worlds apart.
What are the key differences we should keep in mind?
Well, first, the underlying architecture, as we've said. Our brains are wetware biological neurons, complex electrochemical signaling, shaped by millions of years of evolution.
Squishy and slow. relatively speaking.
Compared to silicon, yes. LLMs are based on mathematical transformations, matrix multiplications, essentially running incredibly fast on specialized chips. Similar outputs, like solving a puzzle, can arise from completely different internal processes.
Okay, architecture. What else?
Embodiment is a huge one. Humans learn and understand the world through physical interaction, through our senses, from infancy.
Like learning about gravity.
Exactly. A child learns about gravity by dropping toys, feeling the pull, seeing things fall. That builds a deep, intuitive, grounded understanding. An AI model learns about gravity by reading text descriptions of it.
It knows the word gravity and related words, but doesn't feel it.
Precisely. It lacks that direct sensory grounding in the physical world, which likely affects the nature of its understanding, even if it can manipulate the concept textually.
That seems like a really fundamental difference.
I think it is. And then there's the sheer energy budget. Our brains are incredibly efficient, running on about 20 watts less than a dim light bulb.
Amazing, really.
It is. Training just one of these massive LLMs, like O3, consumes gigawatt hours of electricity, orders and orders of magnitude more energy.
So efficiency could be another measure of intelligence, or at least sustainability.
You could argue that. It's certainly a different constraint. So the big takeaway here is that reaching IQ score parity, or even surpassing humans on these specific tests, absolutely does not equal cognitive parity.
It doesn't mean the AI thinks like a human.
Not at all. Those high scores might, in some cases, just reflect the model's uncanny ability to exploit the narrow format and specific patterns found in these standardized tests.
Okay, so bringing this all together for someone listening, should we care about these AI IQ scores at all? If they're so limited and don't mean cognitive parity, are they just hype?
I wouldn't say they're just hype. I think the answer is a cautious yes. They probably do have some value, but with heavy caveats.
How so? What practical value might they have?
Well, it seems plausible that better performance on these kinds of abstract reasoning and puzzle-solving tasks can sometimes correlate with improvements in other useful areas, like maybe providing more logically coherent coding assistance, demonstrating tighter reasoning in chatbot responses, making fewer simple factual errors or contradictions. It might indicate an improvement in general pattern matching and logical processing.
So a higher score might mean a slightly more capable tool for certain tasks.
It might. But, and this is the crucial but, we absolutely cannot extrapolate that to assume reliability for high-stakes decisions.
Right, the limitations are too significant for that.
Exactly. Anything involving serious real-world consequences, medical diagnosis, financial planning, legal advice, deciding someone's eligibility for something important, we still absolutely need human judgment, human oversight, domain expertise.
Because the AI's understanding might be shallow, or it might lack common sense, or miss crucial context.
All of the above. Current evaluations, including these IQ tests, just don't capture the nuance, the contextual understanding, the ethical considerations needed for those critical applications.
So how should we think about AI IQ then? A proxy for?
I kind of like thinking of it as a measure of potential bandwidth. It tells you something about the system's raw capacity for processing certain kinds of structured information.
Okay, bandwidth, but not necessarily quality or truthfulness.
Right. High bandwidth doesn't guarantee the signal is accurate or safe or beneficial. It just means the pipe is wide. We still need the filters, the safeguards, the audits, and the human experts to make sure what comes through that pipe is actually useful and responsible.
That makes sense. Bandwidth, not wisdom. So looking ahead, how is the field trying to get better at measuring the right things? What's next for AI evaluation?
It's a really active area of research, thankfully. People recognize the limitations of current methods. We're seeing a big push toward establishing standardized prompts.
To make comparisons fair, deal with that prompt alchemy issue.
Exactly. To ensure we're comparing apples to apples when testing different models, reducing the impact of just finding a lucky prompt. There's a lot of interest in developing multimodal exams. Tests that don't just use text, but incorporate images, audio, maybe even video or interaction within simulated environments.
Trying to test understanding beyond just text, closer to how humans experience the world.
That's the idea. To get a better sense of whether the AI can integrate information from different sources and modalities.
Interesting.
We're also likely to see more longitudinal evaluations, tracking how a model's performance and behavior change over time, after it's deployed, as it gets updated or interacts with users, not just a snapshot at release.
And what about the alignment problem?
That's probably the most critical area.
Yeah.
There's a growing focus on creating dedicated alignment leaderboards. These would rank models not just on capability scores like IQ or math, but specifically on metrics related to safety, truthfulness, bias reduction, and resistance to generating harmful content.
So grading them on behavior, not just smarts.
Exactly. The hope is that IQ scores will eventually become just one data point among many in a much richer, more holistic assessment of an AI's overall profile, its capabilities, its limitations, and its alignment with human values.
You mentioned you actually tried testing Toloshi yourself with some custom puzzles. What was that like?
Yeah, it was pretty fascinating, actually. I created some logic puzzles that weren't standard IQ fare, just things I thought required a bit of creative reasoning.
And how did it do?
Honestly, it was impressively fast on most of them. It felt like sparring with someone incredibly quick at spotting patterns, connecting dots textually. It got most of them right, often explaining its reasoning quite well using that chain of thought capability.
I sense a but coming.
But then it made this really elementary mistake on a question involving prime numbers. Something relatively straightforward that frankly surprised me given its performance on the harder puzzles.
Huh. A weird blind spot.
Yeah, exactly. A glitch in the matrix, so to speak. And that unexpected stumble, even amidst all the impressive stuff, was actually a really valuable reminder.
How so?
It just underscored that even with these high scores, we're dealing with systems that are brilliant pattern matchers in many ways, but their understanding can be brittle. They can be tripped up by things a human might find intuitive or obvious. It brought to mind that mountaineering analogy one of the sources used.
Which one was that?
The idea that getting to the summit is optional, getting down is mandatory. Building these incredibly powerful AI models, pushing the capabilities higher and higher, that's the ascent. It's exciting, technically challenging.
Reaching the peak performance.
Right. But deploying them safely, integrating them responsibly into society, managing the risks, that's the descent. And often the descent is where the real danger lies, where fatigue or overconfidence can lead to critical mistakes. We need that humility on the way down.
That's a powerful analogy. Ascent is capability, descent is deployment and safety. So as AI keeps climbing this IQ ladder, maybe faster than any other ladder right now, what's the main takeaway you want to leave people with?
I think the most important thing to hold on to is that intelligence, real, meaningful intelligence, is so much broader and richer than just puzzle-solving speed or pattern matching on a standardized test.
It's more than just G.
So much more. It includes curiosity, empathy, creativity, wisdom, common sense, moral courage, all these things that IQ tests barely touch, if at all.
Mm-hmm.
The fact that AI is now achieving these high scores on certain IQ tests is a significant technical achievement, absolutely. We should acknowledge the progress, but it's just one dimension, one single indicator in a vast landscape of what constitutes intelligence.
So we need perspective.
We need to widen the lens dramatically when we evaluate AI. We need to constantly ask, not just how smart is it according to this one metric, but what is its purpose?
Yeah.
What kind of impact is it having? Is it reliable? Is it fair? Is it beneficial?
Don't get blinded by the IQ number.
Exactly. So while it's interesting to follow these benchmarks, my advice is always keep a salt shaker handy. Take those impressive AI IQ numbers with a grain of salt. See them as indicators of progress in a specific, narrow area, but don't mistake them for the complete picture of AI intelligence, and certainly not as a sign of imminent human-like consciousness or understanding.
That's really valuable advice. Keep the salt shaker handy. And it leaves us with a great question to ponder. As AI climbs the IQ ladder, what are the other ladders? Maybe alignment, maybe common sense, maybe empathy, that we need to ensure it's also ascending? What other metrics truly define the beneficial intelligence we actually want?
That's the critical question for the next phase, isn't it?
Definitely food for thought. Thanks. This has been a fascinating deep dive into what those AI IQ scores really mean and maybe more importantly, what they don't.
My pleasure. Lots to keep watching in this space.